Nice little short one that we're going to modify the worksheet on. This one's about conditional probability of games. And the game that we are choosing here is roulette. There's a lot of cool things to do with roulette. On the roulette wheel, there are 38 total numbers, right? Some of them are red, some of them are black, but there's 2 of them that are green right here, 0 and 00. You can kind of see that obviously I didn't have a colored worksheet right here, but those are our 2 green ones. To indicate red on this board, it's the shaded in color. You can kind of see that by looking here that this is red, and then the black, I just made them white instead, right? So red, black, and etc. So 18 reds, 18 blacks. We might want to write that down. 18 reds, 18 black, and then there's 2 greens. That's a total of 38. And they just kind of spin that wheel and have all these different bets. So you will literally see this on your homework as well. I think it's a different bet layout, but it's the same kind of idea. They just say, let's find the probability of each one of these things betting. So in real life roulette, they give you these chips and you put them on the table where you want to bet stuff at. Let's just kind of dive in. Do you see? They say, let's find the probability of bet H winning. Can you see right here that H, let me use a different color, was placed on this square right here, which was just betting on reds. Are you with me on that? So any red number that shows up. Let's do want over total on this bad boy. How do you feel about there is a total of 38 numbers on the roulette wheel? Rock and roll. How many of them are red? 18, baby. So that is an 18 out of 38. We will reduce those fractions for homework today. So if you do 18 divided by 38, and then it'll give you this crazy little decimal. If I hit math, enter, enter, it should reduce that to 9 out of 19. I think they want the reduced fraction. I'm not 100% sure. If they allow 18 out of 38, rock it, right? So I reduced it. But that one's a very simple one. Probability of I. Here's bet I. Can you kind of see where the I is located on there? They bet on odds, meaning that they just spin the wheel and they want an odd number to show up. Odds are the same as like when it comes to reds and black. There are 18 odd numbers out of the 38 total. The weird ones are 0 and 00. They don't count for even or odd, right? They're not even, they're not odd. So like 1 is an odd number, 2 is an even number, 3 is an odd. So they're still half the odds out of the 1 through 36. So 18 out of 38, which is the same thing as before. 9 out of 19, if I could write that correctly. 9 out of 19. Then let's get into some weirder bets. Probability of bet A winning. Bet A, can we find him on here? They are betting on this one spot right here. Do you see that they bet on the number 30 to show up? So we'll do 1 over total. How do you feel that the total is always going to be 38? There's always 38 possibilities, right? They are literally betting on the number 30. How many 30s are there on the wheel? Just 1. There is a 1 out of 38 chance that that's going to win. But I think I showed you last time that the payout to that would be awesome. Like if they bet $1 on it, they would win $35 back. So it's like 35 to 1. So people would ask a great question. It's like, why would you even want to take that chance? Because it pays better. You know, like the riskier that it is, the better the payment in that situation. So probability of B. Now check it out. I didn't show you this last time because it was a little too much information. Can you see here's the token B that they have right here. See how they split it between 2 different numbers. It's like on 22 and it's on 23. Are you with me on that? So the probability of that, there's still 38 total, but they're actually betting on 2 different numbers. Like if 22 showed up or 23 showed up, that would be a winner. So it's really about how many spots is token B touching. Isn't it touching 2 of them, right? It's touching 22 and it's touching 23. So that would reduce to 1 out of 19. But how about G winning? Where is G? Let's find that puppy. I can't see it. There he is. Here's G in this column right here. I kind of showed you that column bet right here. Let me use that orange highlighter. Here's bet G. They're betting on anything in this column to show up. If you did not know how many are in the column, you could sit there and count them up. But there are 12 of them in that column out of 38 total possibilities. You got a 12 out of 38 chance of winning in that spot. 12 divided by 38. basically like 32% chance of winning. So math enter that. And that is 6 out of 19, baby. Probability of D. D is a weird one. How many spots is token D touching? First, I'll show you where it's at. Token D is right here. How many spots is it touching? 4. Either the 7, the 8, the 10, or the 11. Can you see how it's like they put it on the quad intersection of that? So that's a 4 out of 38 chances of winning that guy. 4 out of 38, which would reduce to 2 out of 19. And then where's J? J is way up here. I'll use this pink highlighter. They're betting on the numbers 1 through 18. So out of the numbers 1 through 18, there are 18 of them, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 18, right? Out of 38. Which, again, back down to your 9 out of 19. Probability of bet C. C's in a new spot. We haven't seen that. It's in this other little dude right here. So C's right here. You see it's in this row right here. Instead of columns and rows, it's betting in that row. How many different options are in this row right here? 3. There you can be a 4, a 5, or a 6. So that's 3 out of 38. It's just about like these weird spots at the end are like in the rows. So 3 out of 38, that will not reduce. And then I just got a couple more. I got to find F. F is in this spot. Let me get some erasing going on because I got a mess. F is right here. It's in this first 12. That's a big kind of indicator that there's 12 items in there in the first 12. That means that if any of these green numbers right here was to hit, you know, when they spun the wheel, you'd be a winner. So there's 12 of them out of the 38. So 12 out of 38, which is 6 out of 19. Then there's 2 other weirdos right here. 2 other weirdos. Probability of E. Look at E. He's in a special spot. E is on this boundary line of these columns, excuse me, of these rows. So not only is it all 3 of these guys right here, but also all 3 of those. Do you see, like E, they split that little boundary on that. It's kind of weird to tell that, right? So that's 6 out of 38. Oops, I hit a button there. 6 out of 38, which is 3 out of 19. And then I am confused on K. I don't really have the answers in front of me. I've just got to kind of know these. But how many things is K touching? K is way up here. Like, what would you call that? It's definitely touching 0 and double 0. Would you consider that touching 2 as well, right? So I would call that, there's 3 different numbers right there out of the 38. I think that is a typo on their part. I think they wanted to split the 0 and the double 0, and it just slid down too far. But I'm going with how it was drawn, so 3 out of 38. But how do you feel about the basic probabilities of one event happening, right? It's always 38 total in that. You just got to see how many like items the weird thing is touching. If you're not sure, hands up, and I will help you with that. Cool? That's the basics. Let's get into the harder part of it, the conditional probability. So the conditional probability, let's write these 2 things down. Like, there are going to be some and statements or some or statements. Or is going to be a union symbol. Homework will sometimes have the union symbol on it, and sometimes it'll say the word or. And is going to be this intersection symbol. So the union symbol looks like the letter U. The intersection symbol is that upside down. So this is the hard part that we got to kind of refresh our memory from stuff we did before break. So what is the probability that somebody bets these 2 tokens, H and B, and they are both winners, right? They are both winners. So let's talk about what H is. What is H bet? Say red. What's H bet? Red, right? Would you believe there's 18 of those, right? There's 18 reds. But for this to happen, for both of these to win, you see how B's betting on 22 and 23? Like, there's only one way that they could both win. Are you with me on that? Is if what number showed up. It's got to be red, and it's got to make these true. So what do you think? Which number's got to win? Just this red 23. Isn't this the only choice that wins both of those bets, right? You know, it is red, and it is 23. So what is the chances of that happening? 1 out of 38. because there was only one thing that happened. Even though there was 18 of them red, would you believe, like, if red 7 showed up, this is a winner, but this is not a winner, right? So they didn't both win, right? You know, it's got to be red 23. This guy wins, and this guy wins in that case. Cool? So that's a weird one in that case. But what if we go down below and said or? Or means just like one of them has to hit. So we're going to do this. We're going to find the probability of H, which we've done above. What's the probability of H hitting? Let's just do it in 38ths. How many reds are there? There's 18 out of 38. Plus, how many winners are there on B? B could win how many different ways? Doesn't have to be both. How about 2, like the 22? Or are you cool? Like B is a winner if 22 rolls or 23 rolls. Are you with me on that? So there's 2 out of 38. But then you have to subtract away their overlap. And it's been a while since we did this, but we did this about 2 weeks ago, where when it was an or statement, we had to do the subtraction. So how many overlaps are there to where this is a winner and this is a winner? It's what we had above, right? How many overlaps are there? Isn't there just one overlap? Isn't red 23 going to make this win and it'll make this win? So we got to subtract away 1 out of 38. So we'll do that all in our calculator, and I don't need to do the 38. It's not a calculator, that's email. I'll do that with just my numerator. So there's 18 ways to win on H. Sorry, guys. Plus 2 ways to win right here, and then I'm going to take away the 1 way that was overlap in that case. So isn't that like 19 out of 38 in that case? That's weird. Or means you got to do the probability of the first dude, the probability of the second dude, add them together, and subtract away their overlap. So let's try a couple more of those. Find the probability of G and J. Let's erase here, and let's just see what's going on with these guys. G is right here. G. This dude wins in this column. And J, where the heck is J? J is in 1 through 18. 1 through 18. So here's what I got to find. In this column, I got to find everybody that's like the intersection of those guys. So is 2 in 1 through 18? If you was to count it, does 2 work? Yep. 5, 1 through 18? Yep. 8? Yep. 11? Yep. 14? Yep. 17? Yep. And would you believe the rest of those do not work in that case because they are not between 1 and 18. So and is like satisfies both of them, right? Is the intersection of those two. It is 1, 2, 3, 4, 5, 6 out of 38 in that case. 6 ways to win that. 6 out of 38. We'll just not reduce it. I'm pretty sure these are capable to like not, you don't have to reduce them on the homework. But what's the probability of G or J? G or J, we do the separate. So probability of G, I'm going to do that first. Wasn't there 12 ways to win at G over 38? J, there are 18 ways to win on that. But I need to subtract away their overlap. And the cool thing is you have already figured out how many they overlap on. Didn't they overlap on 6 of those bad boys, right? So we got to take away 6. So if we just do the arithmetic with our numerators, we should be good. 12 plus 18, take away 6. Isn't that 24 out of 38? Because the or means what's probably the first one, the second one, take away any overlaps. So let's do one more weirdo. Here, let me erase all this nonsense. And then find the probability of F and G. By the way, what I'm trying to say is they might not use the words and ors. I'll just kind of show you. They might have like the union or the intersection symbol when you type it out. I didn't want to go change all those, but the intersection symbol means and. Are we cool with that? And the union symbol means or. It's the same process, just a different symbol. So F, where the heck is F? Right here, first 12. E, right here. So I'm going to use a highlight. F is this green section right here, and E is these 2 orange sections right here. What is the probability of getting F to win and E to win. Do those overlap at all? Orange one over the green one. Do those overlap at all? No way. So that means 0. There is no way that you could roll the wheel once and get F to win and E to win, because they don't overlap in that case. What about OR? So F or these, I do the probability of F. So that is 12 out of 38, excuse me. Probability of E is 6 out of 38. And then subtract away how many they overlap. How many do they overlap? Nothing. So I got to take away nothing, right? So you can put -0 if you wanted to, but there is no overlap. You just add those bad boys up, and that is 18 out of 38. And I hope that kind of makes sense. What's the probability that I win on the green one or the orange one? Well, aren't there 18 different spots that could win in that case out of the 38 in that? So that's really weird. And then something I forgot to put on the worksheet, I'm not going to do those bottom 2 questions down there, so if you want to like cross those out, that's fine. But I added these 2 questions on here. They say find the probability of B with this apostrophe. This means the complement of it. The complement. You might even see it written as like probability of B with the little c as an exponent, the complement. Complement means like it is the complete opposite. So let me ask you this. What if there was a 30% chance of snow today? What's the chances that it does not snow today? 70%. Like they add up to 100%. Are you with me on that? So if you know the probability of B, which you should, because don't you have it up at the first question in the first place, right? The probability of B, which, could you tell me what that is right here? It's right there. How many of these would win on B? 2 out of 38. The complement to that would be 36 out of 38. Are you with me on that? Like, they have to add up to 38 out of 38. So the answer to this guy is 36 out of 38. But they said you should reduce it, so make sure you reduce that fraction. But are you with me? If there's 2 ways to win, then there's 36 ways to not win in that case, because there's only 38 total. What about probability of I complement? I was an odd number. Isn't that 18 out of 38 in that case? What would be the complement to that? If there's 18 ways to win, how many ways are still left? 20 out of 38. And then, of course, you need to reduce that. Does that sound okay? Cool. Let's do some homework.